Thank you for introduction. Thank you for applause. Very excited to be here. My name is Igor. I'm a software engineer at Magento. Before joining Magento, I worked as a system integrator, so you can call me a long-time Magento developer. I'm going to talk about writing extensions best practices. So writing good quality extensions is hard, and some challenges associated with that is that we as developers, we want to write clean code without bugs. We want our extension to be compatible with new Magento releases, so you can upgrade easily. You want extension to be secure because if extension contains vulnerability, merchant can lose money and it's negative PR. If you publish extension with on marketplace, or if you publish it on GitHub, other developers will use it, and there is most likely your extension will do everything except one little thing, and other developer would want to customize your extension, so you want to think about good API and make sure your extension is customizable and extensible. And you want your extension also work with other extensions without conflict. And if you, after extension is written, the work doesn't stop. There are always new features to add, and sometimes there are bugs to fix. Every time you do a change, you need to do a full regression. And if your extension is used by other developers, you also need to worry about backwards compatibility. So the good thing is that you can avoid many of these issues if you follow best practices and Magento technical guidelines. How many people know and follow technical guidelines? Okay, some people know, some people don't. Good. So we at Magento, we face the same challenges. So we collected best practices, just software engineering best practices, added some Magento related things and published that as a document on the dev docs. So everyone at Magento can use it when we architect and develop Magento, and so you guys can also use it. So in this presentation, I will talk about some of the things from technical guidelines and best practices. And first thing I want to talk about is testing and test automation. So as I mentioned, every time you do a change or when you add new feature, you need to somehow test that functionality. And if you don't have automated tests, you need to do that manually. And manual testing is not reliable. Two people executing the same scenarios may execute it differently and get different results. Also, as your extension grows, you add more and more features, and you start spending more and more time on testing. And these unautomated scenarios at some point become very big technical debt, and they start slowing down your development. So if you don't have automated tests, it will start slowing you down. Also, from my personal experience of working as a system integrator, I noticed that sometimes merchants think that you just don't test. If you don't have automated tests and you have very complicated projects with many extensions, and new bugs keep getting discovered, merchants start thinking that you don't test or don't know how to write code. But the thing is that you're trying really hard. It just, without automated tests, it's not possible to control the quality. So in Magento we have the following types of tests: functional, integration, web API, unit, and static tests. Functional tests are very good for covering end-to-end scenarios. You can automate adding product to shopping cart, placing an order, making sure that totals are correct and success message is shown. These tests run in the browser controlled by Selenium, and it's a simulation of a real user. So if your extension consists from UI scenarios, you can automate all of that with functional tests. And if your tests are green, it means you can release your extension, ideally. Yesterday on Dev Exchange, we announced a new MFTF framework. Writing tests with new MFTF framework is very easy. So I recommend to follow update from our quality engineering team and check this framework out when it's released. So the problem is functional tests that they take some time to run because they are executed in the browser. The full Magento application needs to be executed and the page needs to be rendered. Integration tests, they are a little bit faster. With integration tests, you can check that major part of the system can work well together. And for instance, if you have integration tests for a catalog or persistent layer, you can refactor catalog or your persistence layer and receive early feedback because they're much faster than functional tests. The problem is integration tests that they are not executed in the browser and you don't know if your UI will work if your integration tests pass. And if your extension exposes service contracts, you can use Web API tests to cover your REST and SOAP API. And unit test test single units, and in object-oriented programming, single unit usually means one function and method. And if that method uses collaborators, these collaborators needs to be mocked, stopped, or faked to make sure that you are testing a single unit. This is mockist approach. This is what we use at Magento. There is also classicist approach where you don't mock, stop, or fake. You try to use as much real collaborators as possible. In Magento, it's a little bit hard, so we went with classicist approach. What is important to understand about a unit test that because they check individual units, even if you have good coverage with unit tests and they all green, it doesn't mean that your extension actually works. Because units can work well separately, but they may not work together. So the biggest return on your investment you will get from functional integration and Web API tests. If you just starting with writing tests, I would suggest to read about different types and start with functional integration and Web API tests. We also have static tests in Magento. I will talk about that on the next slide. So run static tests on your code. Static tests can help you find problems with code styles, big coupling between classes, usage of obsolete classes, potential security vulnerabilities, undeclared dependencies in Composer.json, and other things. They are already written. You can use a command to run them. This command will run tests on all of the code base. You probably don't want that because these tests are slow when they run on the whole code base. So you can create a list of files at the locations shown on the slide. And it could be a list of files of your extension, a list of modified files, and set environment variable, and then you would be able to run PHP unit in the static folder, and it will run static tests only on changed files. Avoid unnecessary extension conflicts. So what leads to extension conflicts? Changing preferences for classes and interfaces around plugins if the main method is not called, rewriting templates, rewriting layouts, removing blocks from layouts, and depending on specific implementation instead of generic type. What is important to understand here is difference between replacing behavior and extending behavior. If we want to, if you implemented a hashing, a hashing functionality, and you want that hashing functionality to be used in Magento everywhere instead of default one, this is a replacement of the behavior, and in this case, we will have conflicting change, but this is a perfectly valid use case. If we add in field on the form and we want to add a new validator for that specific field, we don't need to replace any existing behavior probably. We need to add new behavior. So in this case, we should use extension mechanisms. And yeah. Always think about extension or extending or replacing behavior, and if you are not replacing behavior, never replace it. Always extend. Another thing that improves compatibility of extensions is always create plugins on the interfaces, because if you create a plugin on specific implementation, someone may change a preference for that interface and your plugin will stop working. And declare observers and plugins in a default area. Use specific areas for presentation related logic. In Magento we have areas, for instance, admin HTML, web API, front-end. So use this area only for presentation related logic. Know and follow security best practices. So every year OWASP publishes top 10 most severe vulnerabilities. Make sure you know what these vulnerabilities are and how to protect from them. Their reports are very helpful. They include description of vulnerability and best practices on how to prevent these vulnerabilities. Use read-only file system. In Magento, we spent a lot of time to make sure Magento can be run on read-only file system, because we had a lot of exploits that were possible because of ability to modify file on the file system. If by running Magento on a read-only file system, you improve your security by a lot. Escape our HTML output in templates. 2.2 comes with improved library for output escaping. Make sure you use it in templates and blocks. Don't use native PHP unserialize. Native PHP unserialize is very insecure. If you have a class on a file system that contains dangerous backup or destruct methods that can be exploited, attacker can pass serialized object of that class, and these methods can be invoked. In 2.2 we have serialized libraries that contains JSON implementation, which we recommend to use. If you serialize in big chunks of data, we also provide serialized implementation that does not unserialize object. It works only with arrays. It's a little bit safer, and if you need higher performance, you can use that. And of course, install latest patches and upgrade Magento. Follow the modularity. So modularity is very important. Declare all dependencies in composer JSON. Just by doing so, you can reveal many problems with modularity. I'll talk about this on the next slide. Reference only API code of the modules. This would make upgrades to the new versions easier. In 2.2, we marked a lot of code with API annotation, and this is the API we want you to use. If you depend on classes or interfaces or use anything that is not marked with API annotation, there might be problems during the upgrade. And if your extension is used by other developers, you can also use this API annotation to mark what you what you want to call your API of your extension. There is a document on our dev docs about which version of the extensions you need to depend on, depending on what kind of API you use. It's basically if you depend on the API, you depend on the major version of the module. If you use SPI, you depend on minor version module. And if you have dependencies on something that is not marked with API annotation, you need to depend on a patch version. It's a little bit more complicated than this, because sometimes API and SPI means mixed together. So check out this document to make sure that you depend on correct version of the module. Okay, dependencies in Composer.json. Let's take a look at this example. Let's say that we want to write a module, and we want this module to work in Community and Enterprise Edition, and it has some dependencies on the Enterprise Edition API. If we put all of the dependencies in Composer.json, this module simply will not install on Community Edition because it has dependency on the Enterprise. And while it's possible to make it work with optional dependencies or soft dependencies, the recommended way to go is to create two modules. One module for Community Edition that will not have any knowledge on Magento Enterprise, and another module for Magento Enterprise Edition that will extend module in Community Edition using extension points that you can create, and it will depend on Magento Enterprise Edition and Magento Enterprise Edition specific behavior. So this solution is modular, and it also has testing benefits. I want to talk now about some problems with the code and later about principles that I think would help you make your code cleaner and more robust. So one of the problems that we realized that Magento are causing a lot of bugs and results in inconvenient API is temporal coupling. So let's take a look at this example. Let's say that we have a URL class that has a get method, and if we pass URI, it would return us full URL. The problem with this class that if you don't call set base URL method, it would throw an exception. And it's actually good that it throws an exception. It makes a problem a little smaller, but in real life, in some cases, this exception will not be thrown. So it would just work incorrectly, and it would lead to hidden bugs in real life. So we have here a dependency on the order of execution, and very confusing API. This base URL needs to be called before other method, otherwise it would not work. This is called temporal coupling. The way to resolve this problem is make sure that there is a single way of using the API and no dependency on the order of calling the methods. So we can pass this base URL as a constructor argument if it's runtime configuration, or as a method parameter if it's a parameter of the operation. This way we don't have dependency on the order of execution, and the API is clear. Another example of temporal coupling is using registries. So developers who have experience with Magento 1 probably seen this examples in Magento 1. In Magento 2 we're trying to use another approach. Let's take a look at this example. So we have we're trying to load product in the controller, then we put this product into registry, and later in our block we get product from the registry and returns the name. The problem with this code is that if for some reason we forgot why do we put product in the registry in the controller and remove that line, our view will break. Or if we would decide to reuse this view in some other place that render it by controllers that doesn't put product in the registry, the view will not work. So this code is also not very reusable. And one of the options to refactor this code is use repository. So in both places, we can use the repository to get product by SKU. Repository will cache loaded product, so there will be no performance implications. And if we don't need product in the controller anymore, we can remove it. If we want to reuse our view in some other place, we can also do that because it doesn't depend on the controller. We probably would want to add the ability to configure this view with a name of get parameters that would contain SKU, but that's it. This solution is more flexible, no dependency on between classes, and when these classes will be initialized, and as a result, we don't have temporal coupling. So, another principle that if you follow it, you will get more flexibility, and your design would be much better. Is favor composition over inheritance. So developers who have Magento 1 experience know that in Magento 1 extension, inheritance was one of the main extension mechanisms. In Magento 2, we use a different extension mechanism. We use composition. We use dependency injection. We don't want anymore our classes to be extended, and we don't design for that. Let's take a look at this example. So let's say that in our module we have a few controllers that have the same validation and hash generation logic. And the first thing that comes to mind, okay, let's create abstract class and let's have all of the controllers extend that abstract class, and that abstract class would contain these two methods. And the problem is this, and let's see what are problems with this approach. The first problem that now our controllers are bigger. They not focused on one thing. In addition to dispatching requests, they do validation, some hash generation. If someone if other developer uses this extension and he wants to change validation logic, he will have to overwrite all of the controllers because he cannot substitute the parent. And also, these methods are protected. And as they are protected, they become part of the API that you need support. So if another developer extends this abstract class, you need to be very careful when you do changes to these methods. The way to refactor this code is to move not related to controller behavior to another interfaces and inject as dependencies. So in this case, our classes are smaller. They focused on one thing. This design is more flexible because you can inject in every controller different validators or hash generators if you want. And of course, it's more testable. And also, it's easy to understand because if you have everything in one class, it's hard to understand. In reality, this controller, this abstract controller would be would not contain just two methods. It could contain 20 methods, and it will be hard to support. Solid principles. So solid principles you don't need to avoid, you need to follow them, and it's hard to describe solid principles in one slide. They deserve a 1 hour presentation, but I just want to tell you so you can read about them. So single responsibility. If you follow single responsibility, says that every class should have only one responsibility or one reason to change. If you follow these principles, your classes will be smaller, and as a result, the behavior that you want to achieve would be you would have more flexibility in composing behavior that you want to achieve. Because this is one of the benefits of object-oriented programming. you can compose different behaviors at runtime by providing by replacing objects in the object tree. Open-close principles. It's all about providing extension points. If you want your extension to be used by other developers, think about how they're going to use it and make sure that they can extend it without modifying code of your extension. The good thing that if on Magento, a lot of extension mechanisms will be available by default, but always think about extensibility of your extension. Make sure that you have a good API and third-party developers can use plugins. It doesn't mean that you need to make all of your methods public. If you think about that, it probably means that you need to use some other type of configuration or make sure it can be extended via DI. The scope substitution principle says that derived types should be compatible with base types. So if you extend some class, make sure that the overwritten method does not handle less arguments than original, is that it does not return more than original, or it doesn't throw new exceptions. With the exceptions that if these exceptions extend exceptions defined on original type. Interface segregation says that a smaller interface is better than a big one, so make sure you follow these principles. It's kind of similar to single responsibility. And dependency inversion says that low-level modules should not depend on high-level modules. All should depend on abstraction, and details should not depend on abstractions. I'm sorry, abstraction should not depend on details. Details should depend on abstraction. It's about replacing the behavior. If you want two modules or two classes be changed independently, you create abstraction layer, usually these interfaces, and you make sure that this classes or this module depends on these interfaces or this layer. So no one modifies core anymore, I think, so I updated the mem. Follow technical guidelines. Go to the docs page. There is a link on main page. Make sure you check out technical guidelines and follow it. I don't have time for questions. Okay. Thank you.